nerve centers and give information, basis of information exchange. And now we should speak about the second role, about the second type of electrical signaling in CNS, about the role of inhibition. So what's inhibition, what inhibition is, and which role of inhibition we know important for CNS functioning. So what is inhibition? Who knows? Who may tell the definition of inhibition? How do we define inhibition in CNS? So what's its definition? Decrease of disappearance of excitations. Yeah. You know that if we throw the stone into the water, we see the circles, the waves of the water. Yeah? And these waves, they go away from the place of this source of the waves where the stone was thrown into the water. And these waves, they slightly and slowly disappear. They go and they become lower and lower amplitude, and finally they disappear on some distance. So that's also may be like the inhibition, because that's also the disappearance of the waves, right? Due to low energy loss, they disappear. So is it possible to compare, to tell that this energy usage, energy loss may cause inhibition in CNS? That may be also due to energy of how we tell that propagation through the nerves is losing almost no energy. I hope you remember this law of nerve impulse propagation through the nerves. There should be anatomical, nerves should be without any anatomical functional interruptions. There are two sides, propagation, and third law of propagation of the nerves. You remember, I hope that's from the first colloq, that there is almost no energy usage under this propagation of nerves, but still there is some very low, and that may be the reason for inhibition, that the process in the CNS, they lose the energy and somehow they become inhibited. Is it proper basis for inhibition due to energy loss? In your definition, that may be due to energy loss, inhibition. Because you tell that inhibition is disappearance of some process. There may be the input of energy loss. And that's why the process disappears, right? So is it the inhibition, the proper definition of inhibition? Yes, no? Yes, no? Is it possible that our process become inhibited in the brain or somewhere in the body due to energy loss? Would be that proper definition of inhibition or no? Or not? No, because inhibition, first part of definition, first that we telling in the definition for inhibition, that inhibition is active process. It's not the energy loss and somehow inhibited process. That's active process which we excite, special process of excitation, which we use specially to inhibit some other activity. So that's the energy, that's the excitation which we apply to inhibit some other process. So the first part of the definition we should tell that inhibition is the active process. That's the excitation which is inhibiting other activity, which is decreasing or totally disappearing or preventing some activity. It's important that we may decrease or exclude some process which was previously activated, or we may also apply special activity to prevent other activity. So that's third part of possible inhibition, that we may prevent other activity. That's important, because there are two types of inhibition, which is returning to previously activated process, and thus this type of inhibition decrease or totally inhibit other activity. Or second type of inhibition, that we may before the activation of the process, apply special input, inhibitory input, and prevent this activity. That's important. That's the third type of inhibition. So that would be proper inhibition. That inhibition is active process. We apply special input, special activation, which is inhibiting. That's not due to energy loss or passive disappearance. That's active disappearance of other activity. And we decrease, prevent, or totally reduce total, decrease total disappearance of the process. So that would be proper definition of inhibition. That's important to note that that's active. So we always should be able to find some activity which is inhibiting other process. There should be always some activity which is inhibitory activity. So we should always, in all our schemes, which we will draw now on the desk, we should be able to show there this inhibitory excitation. So then we should tell some special, we should discuss some special types of inhibition, how they organized in neuronal connections, how they are functioning, special types of inhibition. Special neuronal nets which are inducing, which were when we observe inhibition. In general, there are many nerve centers in the brain. These nerve centers, they are interacting to each other, they are together functioning and giving us the function of the whole body. They are interacting always. They are the center of the hunger, they are the center of the thirsty, center of blood, arterial blood pressure and cardiac function. There is center of respiratory function, there is center of higher nervous functions. All these centers, they're interacting always. Now you're sitting here, you're feeling the temperature in the room, you're feeling the information from your eyes, from your ears, from all your receptors, external and internal as well. And you have some motivations. If you are hunger, then you have two motivations. First, social motivation to be here on the lesson, to have some marks on physiology and so on, to obtain a colloque and going further to finish university. That's social motivation. Then there were possible other second motivation of hunger, for example, or thirsty. And in our brain we have two centers activity, and they are interacting to each other somehow. And which final decision brain would be able to take, and brain would behave the whole body in the direction of going to eat or direction to stay here in the lesson, to listen and to writing the experiments. So what would be the important for this decision? How they would interact to each other, these centers. If your motivation of feeding, if your feeding motivation would be upper, use upper, which second. No, upper, this one, yeah. It's really close. Okay. So, what would be of importance for the brain to decide which motivation is more important? There would be the usefulness of this motivation for the survival. This usefulness would be of importance for the brain, for its decision making, which motivation is more important for the survival. If, in your case, feeding motivation would be highest and higher in your own life than this social motivation, then you would go from the lesson to eat something and you would leave the lesson. But if most social motivation would be higher to stay on the lesson, then you would leave your feeding motivation for a while and stay here on the lesson. So, but still in that case, feeding motivation would be present in your brain. If you will stay here, your feeding motivation would be present in your brain. It would excite the neurons from hypothalamic area, and these neurons of feeding motivation, effector input from the output, effector output from the brain in accordance to feeding motivation, it should disappear somehow. Because your arms, if you stay on the lesson, without any food, would never make some feeding behavior. So you should somehow exclude this second motivation from the excitation circles in the brain. For that reason, we need inhibition. So the question is, what's the role of inhibition? The role of inhibition is to exclude non-dominant types of activity, to suppress non-dominant types of activity in the brain and in the body. That's the reason, that's the function of inhibition in the body, in the brain. To exclude all others types of activity which are non-dominant in some time. You think and usually answers that the function of inhibition is to prevent overexcitation. That's not the function of inhibition, because we may find overexcitation of the neurons under the influence of glutamate, for example. We call this glutamatergic cytotoxicity. Neurons dying due to overexcitation in the large amount of glutamate. Glutamate causes activation of neurons, calcium enters into the neurons, and neurons become neurons dying. So, overexcitation of neurons is usually observable in the brain, and it's used under some cases of specialization of neurons, in memory process that's important, and in some pathological ischemical damage of neurons. So that's not the inhibition which prevents this overexcitation. Inhibition has nothing to in this prevention of overexcitation. That's not the role of inhibition to prevent overexcitation, as you think usually. That's not the role. But the role of inhibition is to exclude non-important, non-dominant excitations in the brain, to allow for dominant excitation to take the control over effector nerve and humoral pathways from the brain. If rabbit, for example, sitting and eating some food, but suddenly his brain, his circles, his effectors, muscles, autonomic nervous system is busy with this feeding behavior. Everything is involved into this feeding behavior. But suddenly this rabbit observes the fox, and there is second motivation center activated of other motivation, and escape behavior should take the control. Other type of excitation in the brain, escape behavior, should take the control over the muscles and all other organs. The heart, the brain, the arterial blood pressure should change. Gastrointestinal tract should inhibit its own activity to allow the blood to go into the muscles, skeletal muscles, to escape from this dangerous fox. So there is change, there should be primal change of activity in the brain. Feeding behavior should be broken, but escape behavior should take the control over the muscles and other organs. For that reason, we need inhibition, and escape, motivation of escaping behavior are also located in the hypothalamic area of these neurons. They take the control over the muscles, over all other organs, and to exclude the control of feeding center, it's using inhibition. So that's the role of inhibition, to allow us to change the activity of the brain and to allow to dominant excitation take the control over the effector functions of the body, over the muscles, autonomic nervous centers, humoral outputs from the brain. So that's the role of inhibition. Now, MCQ, 5 mistakes, Nurul Nirvana, that's mark 3, right? Then,